So it's time to look at the oxidation number. And what is oxidation number and why it is different from ionic charge? So first, many kids they face difference in distinguishing between that why Na plus, it's an ion and it has a plus charge of 1 plus, but it also has an oxidation number of plus 1. So that the kids sometimes may merge that uh, the kids sometimes may merge that concept, and it's not a big deal. But when you say that, okay, when oxygen in H2O has a oxidation number of -2, but the charge is 0, but the charge is 0. So why then it may sound confusing. Then what is oxidation number and why it has an oxidation number of -2 but a charge of 0? So we'll see that. Uh, hmm. So uh, proceeding further is that the oxidation number shows how many electrons an atom has gained, lost, or shared in a compound. It is determined by set of rules. You should know that oxidation number is a made-up number. It is a made-up number that we have chemists have made to, make easier for us to determine the amount of electrons an element has or an atom has, gained, lost, shared in a compound. And there are three main set of rules that you should know. With the help of that, you can determine the oxidation number. So the first rule is the oxidation number of all elements in a free state is 0. For example, Na 0, Cl2 0, Mg 0, and phosphorus is also 0. So that means any element in a free state is 0. Let me add some more examples for your easy. So in nitrogen would be 0. For your aluminum, it would be also 0. In the free state would be 0. So the second point states that the oxidation number of a simple ion consisting of a single element has the same size and sign as the charge of the ion. Thus, Na plus, Mg2 plus, Al3 plus, Cl minus, sulfur 2 minus are 1 plus, 2 plus, 3 plus, 1 minus, 2 minus respectively. What that means is that we have sodium in the free state. The sodium in the free state, Na0, it is Na0, right, in the free state. But when sodium loses an electron, it loses an electron to become an ion. So sodium loses an electron, Na plus electron. When the sodium loses an electron, it becomes an ion. So the ionic state, the ionic charge is equal to the charge of the ionic charge is equal to the oxidation number. So if there's plus ionic charge, there's a 1 plus ionic charge. That means the oxidation number is plus 1. And let's further conclude with another example of magnesium. So when Mg here, in the first example, in the first rule, that Mg is in the free state, the oxidation number is 0. But when Mg loses an electron, Mg2 plus 2 electrons in the oxidation. So the 2 plus ionic charge on magnesium is same as the oxidation number. So the ionic charge here is 2 plus. So ionic charge is 2 plus, whereas the ionic charge is 2 plus, whereas the oxidation number is also plus 2. So it's same as the oxidation number, that is plus 2 as well. Well, that only works for ions. These two rules only works for ions. The second rule only works for ions. But the third rule states that the algebraic sum of oxidation numbers of all elements in a compound is 0. So the algebraic sum of oxidation numbers of all elements in a compound is 0. That means the H2O, we can see this is H2O, right? So the overall oxidation number of all the elements in this compound, concluding of hydrogen and oxygen, would be 0. But if we want to find out the individual oxidation number of hydrogen or either oxygen, we can use the algebraic equation to find that out. And I'll show you how. So we know that hydrogen has a valency of 1. That means it loses electron to oxygen. So it would be plus 1 for hydrogen. We have 2 hydrogens and we want to find out the oxidation number of oxygen. But here I will use x, algebraic sum, and would use a plus sign and an x, which would be equal to 0. So here it would be 2 plus x is equal to 0, and here x is equals to minus 2. So the algebraic sum, if we solve the equation, we see that the oxidation number of oxygen is -2. Now we'll look at some more examples. Hmm. So we're looking at some examples to find the oxidation number of an element in a compound. The first and uh, the first and the most popular oxidizing agent that we have is KMnO4. That's the oxidizing agent, which can also be called the electron thief. Just to give you a background, if you haven't watched the first video, it's uploaded on the channel. Electron thief. If you want to find out the oxidation number of the manganese, the Mn is the manganese, it is a transition element. Transition element has variable oxidation states, meaning in a given time it can have multiple oxidation numbers. In a compound it may have 2 plus, but in a compound like KMnO4 it has a different oxidation state. So if you want to find out the oxidation number of the manganese, you would, using the algebraic method, you can find that out. So yeah, let's proceed further. Here you can see that I have made a template. So the oxidation number of Ka is plus the oxidation number of manganese plus 4 oxidation number of O. So if you look carefully at the molecular formula of KMnO4, you can see there's only one atom of K, there's one atom of manganese, but there are 4 atoms of the oxygen. So in the equation as well, I mentioned only oxidation number of K plus oxidation number of manganese plus 4 multiplied by the oxidation number of O. Likewise, the algebraic equation, you have a single variable, and that is x. X is your variable. So, and the known are the oxidation number of K and oxidation number of O. We know the oxidation number of K is plus. The oxidation of manganese we don't know, so we're denoting it by X, and the oxidation number of oxygen is -2. So we made an algebraic equation like that. So it's +1 plus X plus -2 multiplied by 4, -2 is the oxidation number of oxygen, multiplied by 4 equals to 0. So, and we've solved it. So it's -8 now. This is +1 and this x. So I have used, I haven't used many steps in it. But if any of you is confused, let me tell you the further steps. So what happens is x is equals to -7 after that equals to 0. And then we send this, we, add +7 on both sides to cancel this, and then +7 here. This is a mathematical rule. So that's why the final answer becomes x is equal to +7. This is your basic math skills, basic algebraic skills that you should know while solving the oxidation numbers. Okay, so let's move to another example. So here we have to find out the oxidation number of chromium atom in K2Cr2O7. K2Cr2O7, that's potassium dichromate, that's another oxidizing agent. That means this is the electron thief. Okay. So as you can see, the molecular formula is K2Cr2O7. We have 2 potassium atoms, we have 2 chromium atom, and 7 oxygen atoms. Likewise, we have to make a template like this. So it's 2 potassium, 2 multiplied by the oxidation of potassium, plus 2 multiplied by the oxidation number of chromium, and 4 multiplied by the oxidation number of oxygen, which would be equal to 0. So the oxidation number of potassium is +1, is from the group 1, and the oxidation number of chromium is X. We don't know that, we have to find it out. And the oxidation number of O, oxygen, is -2, that we know because it belongs from group 16, and that means it needs 2 electrons to fill its last shell. From that, we see that for some elements, the oxidation numbers are fixed, like hydrogen is fixed, for potassium is fixed, and for oxygen is also fixed. But except in peroxides, oxidation has oxidation number of -1, but that's not your concern right now. So we make an algebraic equation like this. So this I have shown here. So it's 2 plus 1 plus 2. The +1 is from potassium, but the 2 is X of the chromium. And then oxygen, we have 7 atoms of oxygen. So that means it will be 7 multiplied by -2 would be equal to 0. So we further solve that. It's 2, that's 2x, and that's 14. If we further solve that, we get the, we, if we further solve that equation, it would be 2 plus 2x is equal to +14 if we send 14 there. And then we have and then we send 2 there as well, so it would be 2x plus is equal to 12 that we've seen. And then the x we divide it by 2, so it would be 2x is equal to +12. Then the x would be 12 over 6. Sorry, the x would be 12 over 2, and then the final answer would be x is equal to +6 that we have shown here. I'll give you a minute to absorb all that thing. So yeah, this is how you would find out the oxidation numbers of elements. And now in this video, I explain what are oxidation numbers, what are the three rules to determine the oxidation numbers, and how you would find out the oxidation numbers in a molecular compound. So thanks for watching this video.